So it looks long, but it's actually probably a little bit shorter than the paragraph looks. So we have a triangle ABC with center O.
It should be the in circle, right?
Oh, what?
The triangle is inscribed in the circle. It should be in circle.
Oh, are you saying this should be the in circle?
Yeah, like that's how. I think it's the opposite, right? Triangle is being inscribed in the circle. Oh, sorry. I'm sorry.
No.
That's all right.
Yeah.
Not a problem. All right, so we have a circle with center A.
Yeah, it also gets stuck with me what is inscribed. Like those terms always jumble into it. Yeah, pretty normal.
No, I get confused a lot by that kind of stuff too. So yeah, it's a big problem statement, but yeah, I'm telling you the diagram is not as complicated as the statement makes it look. So I'm just going to draw it like that. F and G are the 2 points of intersections of the circles. And this just says F lies on arc AB and G lies on arc AC, which we know. The circumcircles of BDF and CEG they meet the two sides at 2 points. So K and L, so I'm going to rename those. FK and GL intersect at X. And we want to show that A, X, and O are collinear.
The first thing gets into head seeing this diagram is radical axis, because there are a bunch of circles intersecting, and the radical axis theorem is just good to be played here.
Yeah, it feels like there has to be some kind of radical axis theorem. So,
more likely radical center thing.
Okay, so now the thing is we have 3 circles all passing through point F. So we don't want to use it on those 3. And we also have 3 passing through point G. But maybe we could try, so if we take the intersection of F, B, and GC, it has to be, let's see.
Yes, you can produce them. Let's see.
Yeah, I guess we kind of have to figure out what the radical axis of these 2 circles are, right? FDB and GEC. Yeah, so this point would lie on the radical axis of those 2. I'm just gonna hide those for now, but let me move, I'm trying to make some room. Put this as high as possible. There we go, that looks a little better. Okay. Yeah, so let's see. Yeah, what would the radical axis of these 2 circles be? I guess I could try drawing it and see what happens. So here's one way that I draw the radical axis. Whoa, that's pretty crazy. So if I draw the tangents, hold on just a sec. Is FG tangent to both circles? I doubt that would be true. Ah, it looks like, yeah, no, that's not true. But what we can do, I'm just going to draw the radical axis of those two circles. Okay, so it should be like the line NP. Okay, so this line NP, I'm just going to hide a bunch of stuff, but that line NP is the radical axis. So maybe that'll tell us something. Okay, so in fact, I'll even hide NP. So that line is the radical axis. So at BF and GC have to intersect on it. Trying to So BF and GC should intersect on it. Yeah, I'm not sure. Yeah, so that's using the radical axis theorem. I'm not sure how much that does, but yeah, it's there. I'm going to erase some stuff just because I think that it gets a little messy. Yeah.
Can you check whether AD and AE are tangents to BDK and ECG?
So Ramakrishna, I'm kind of just undoing what we did before. So you want to see if AD and AE are tangent to the two circles?
Yes.
I think there's another intersection point here, H. So yeah, I don't think they are. But Ramakrishna, do you know? Really, we haven't done too much other than the problem statement. All right. Okay, so we want to use the fact that AD is equal to AE is equal to AF is equal to AG. So if AX and O are collinear, I think that means XF is equal to XG, right? Yeah. I mean, basically, we want to show XF is equal to XG. And we can use power of a point. So XK times XF is the power of X with respect to that circle. And XL times XG is the power of X with respect to this circle. So really, we want to show that the ratio of the two powers is XK over XL. I kind of like that. So how do we show? I think X has to lie on a, so I'm going to cheat a little bit here, but I'm going to show the trace of X. If we, yeah, I think X, Oh, well, yeah, it has to lie in the line AO, but if the problem is true. But yeah, we want to show the ratio of the powers of x with respect to those two circles is xk over xl. What if I drew xb and xc? Hmm.
I actually have one more idea here.
Okay.
If we can somehow prove that let's say we connect AX and O, like for instance, let's just assume that they are collinear.
Okay.
We join AX and O. Now the point where the line AO meets BC, let's just name anything. Just mark a point.
Okay. Just a sec. Hold on one sec. Let me.
Oh,
Yeah, I'm just getting rid of that. All right.
okay. This diagram doesn't look so promising. Okay, my idea just failed in this diagram. So my idea was to prove that X is the center of a circle which lies, which is tangent to the original circle and also to the chord BC. And we can use that property of that circle that the center of that circle and the original circle are collinear. So I thought to use that idea.
Are you sure I should erase it, or let's see?
Yeah. Okay, it doesn't work now.
All right. Yeah, but if you see it again and you think it might work, yeah, just let me know.
Yeah.
All right. So what if? So one way. Sometimes I'll do the problems this way. What I'll do is, like, I'll draw in the segment AO, and then I'll try to show that FK and GL cut AO in the same ratio. Let's see. Is FK? I wonder if FKGL is cyclic. Let me check that. No. Okay. Let's see. I'm just going to draw on point X again. All right. Okay, so we want to show 3 lines are collinear. Can we use Cheva? Wonder if we could use the Sarg's theorem in a way. So how would we use the Sarg's? Basically, let's try the Sarg's theorem. So we want to show that FGO is perspective with AKL. Okay, so let's see. So if we apply Desargues' theorem, we can turn a concurrency into, so that's kind of interesting. Let's try that. So let me try to make the diagram nicer. So XFG is isosceles. Yeah.
Yes.
If we can prove XFG is isosceles, that would solve the problem. So do you see how to prove that? Because that if we show XFG is isosceles, we've solved the problem. See. I was thinking if we can show HI and J are collinear, that would solve the problem. It's kind of a, let's see. I'm just going to erase that stuff. I kind of don't think. Yeah, I wonder if this just comes down to an angle chase. So if we can show angle OFX is equal to angle OGX, that would solve the problem. Can you prove that angle XFG, if the problem is true, then XFG is isosceles. If we can show XFG is isosceles, that would solve the problem. And I think I might be able to do it by showing that XFOG is a kite.
But how do we use the two circles of quadrilateral BFKD and ELGC?
Yeah, I think I might have an idea here. Let me try something. I'm going to do a little calculation. So let's try this. So angle XFO is equal to angle XFB minus angle OFB. Is equal to angle KFB minus I think I have an idea here. So angle KFB and then angle OFB is 1/2 of B. Okay. And angle FOB is 2 angle FOA. So let's see. Someone said something in the chat. AO is perpendicular to FG. I don't. So yeah, AO is perpendicular to FG. That's true. Yeah, if we could show, no, I think you mean we want to show angle FPX is 90 degrees. I'm just looking at what Ramakrishna Sen is saying. Yeah, I think that would work. I'm just going to continue with this idea for now and see where it goes. But if not, maybe I'll get back to that. Yeah, that's kind of what so you're a John. That's kind of what I'm trying to do. I'm trying to prove that angle XFG is isosceles through an angle chase. So I guess really I'm trying to show that XFOG is a kite, and then from there it would follow pretty easily. So this is equal to angle KFB minus 90 plus angle FAB. So KFB plus is equivalent. Yeah, I'm trying to show FXG as isosceles. Okay, so KFB plus FAB. wonder if triangle FAB is similar to triangle GCA. So actually angle FBA is equal to angle GCA because they intercept equal arcs. I think we might be very close here. Okay, yeah, I think I think I've kind of got it here. Okay, so
I think you should join AD and E, then FD and EG, because angle FDK and angle ELG will be equal.
FDK and ELG.
FBA, sorry, FDK and LEG.
Yeah, that's true.
And
FDK,
also AD, since AD equals to E, so angle AD equals to angle AED.
yeah,
So there is a whole angle equal in those two.
I'm going to draw that in, but I think this angle chase, I think we have enough to finish. So basically, hold on just a sec. So so how did I do this? I had an idea in my head. I forgot what my idea was. I feel like I had this. Let's see. Yeah, okay. I think I remember it now. Yeah. Okay. B. Okay. Then I'm going to combine the 180 and the 90. So that's BA. An angle FKB is angle FAB for, yeah. So I might be going in circles here. Is that right? Not sure if that's right. Yeah, I don't think we've gotten anywhere though with this. Let's see. Yeah, no, I think I just went in a circle with this. I thought I had it. Let me see. You got it. All right. One sec, let me plug in my computer. FG is the radical axis. That's true. That's true. Yeah, OA is perpendicular to FG. I agree with that. Yeah. Oh, it's all right. It's not a problem. Let's see. So yeah, we have so many equal angles here. I feel like it has to be solved by an angle chase somehow. I think maybe I have it. Hold on just a sec. So AFX is equal to AFD minus KFD. So it's very possible that I'm making this whole angle chase longer than it has to be, but this is 90 minus angle FBA minus angle AFD minus angle KFD. Okay. And angle AFD is the same as angle ADF. See. I feel like we're so close. I feel like this has to finish just any second. Yeah, this has to just be an angle chase. So so okay, so we want to show that angle ABC minus angle FDB is equal to angle ACB minus angle GEC. I wonder if that's the same as showing.
I think angle FGD, and if you join like DG and FE, then and also FG.
Oh, what? Oh, FG?
FG, yes. So angle FGE will be equals to angle FDB. And angle FDB is also equals to angle FKB.
FDB is FKB. Or
FKB equals, yes, FKB equals angle FDB equals angle FGE.
Okay, so FDB is equal to FGE. see that. I'm just trying to think. So FDB is equal to FGE. I agree with that. Now I'm trying to see what we can do from there. Yeah, I could try that. I'll just draw on those points for the heck of it. But I feel like we're really close, because if we could show XFO is equal to XGO, that would solve the problem. And XFO is equal to this. And FBA, we know, is equal to, yeah, it's just,
Is there some mistake in a diagram because AXOR not looking collinear?
I think they are.
Oh, sorry.
All right. But yeah. Okay. Yeah, I'm seeing a couple different things here. So this angle FDB, it's equal to angle FGE. Like I think it was Psi that said it, and that's half of angle FAE. Circle BHI. You try that. Yep, you're right. BHIC does look cyclic. So I'm gonna write out a few steps here. So oh no, this is half of angle FAE. Let me try something. So yeah, this is a little tricky actually. So I was thinking, can we show FD? I wonder if it's true that FD and AB makes the same angle as AC and GE. Let me check if that's true. So That's 93, and that's also 93. Yeah, I think if we can show those are always the same, then that would solve the problem. Yeah, okay. Uh, just a sec. Make that bigger. There we go. I think that would mean is NP parallel to BC? Looks like it, yeah. Okay, so how would we prove that? Okay, I think I have it. Just thinking through this.
Aren't angle if angle aren't an AD and E angle bisectors of FDG and FEG?
Oh, you're wondering if they're angle bisectors? I don't know. I don't think so, but let me check.
Because you have to also prove that BMD equals angle EJC. So anyhow, you have to find some link to that.
Yeah, so I actually just figured out how to prove that BMD is equal to EJC. So now I could show you how I figured that out. But now I'm trying to see if that actually does solve the problem. Yeah, okay. I do have a solution. It's kind of complicated. I do have a solution though. I feel like there has to be a simpler way. So I'll just write up my solution for now, and then maybe we could think if there's a way to simplify it. Okay, I'm going to hide that circle for just a second. All right, whoops. Didn't want to hide all that text. I'm going to delete that, or I'll go hide it. Okay, so thought I had a solution. FDB. I think I might have gotten my signs wrong somewhere here. Wait, oh, this is plus. Yeah, okay. So, okay, so let's just write this out a little bit. Oops. Angle FBA. And then minus angle ADB plus that's true. And then I'm going to just move this up. And then I'm going to, so this is like really long, so I'm 100% sure there's a faster way to do this, but I'm just going to write it out for now. Okay, so angle BMD is half the sum of the two intercepted arcs. So it's half of arc AF plus half of arc BP. I might put this problem in a separate video, just because it's so long. Okay, and then, so that's angle XFO is equal to all this. And then we can do the exact same argument with angle XGO. Let me do this. But then everything in the first expression matches the second. So angle FBA is equal to angle GCA because arc AF is equal to arc AG. And then angle ADB is equal to angle AEC because triangle AD is isosceles. And then again, arc AF is equal to arc AG because AF is equal to AG. And then arc BP, I'm going to show is equal to arc CN. So I'm going to show that BC is parallel to NP. So see how I did that. Because PN DB So this is like a super complicated angle chase, but basically everything in this top expression equals the bottom expression. So we have angle XFO is equal to angle XGO. And so from there, and yeah, FO equals GO. So XFOG is a kite. And so AO is perpendicular to FG, so AXO, or I'll just add this. And then so this was super complicated, but does this proof make sense to everyone?
Yes, partly. I have to see the video once or twice.
Yeah, I'm sure that this is more calculation than is necessary. I'm like 100% sure there's a way to simplify this. Yeah, so I guess this will be the final problem. And then if you guys see a simpler way to do this, feel free to post it on the forum because yeah, I definitely like to see it. Oh yeah, yep, it definitely was quite some effort. So thanks everyone for showing up and participating. I'm glad this time worked out for all of you. And I had a lot of fun doing this. I learned a lot, especially that problem with like the Humpty point. I'd never seen that before. So yeah, thanks everyone for participating, and I think we'll stop it right here. Have a good day, everyone. All right.